So the example that I'm going to show you right here is actually, it is number 15 in your textbook. And on this particular problem, sigma is equal to 12 and the sample size is actually going to be equal to 9. I got kind of cut off here, but you can find the other wording in the book. And it also looks like the mu value is going to be equal to 60. So just to demonstrate this new z value formula, z is equal to, remember, it's going to be x bar minus mu divided by sigma over the square root of n. So if we were doing letter A, I would draw my curve, and of course in the middle we always put the mean, so the mean is 60, and it looks like we want greater than 63. So I draw my 63, and notice I'm highlighting to the right of 63. So we want to convert 63 into a z-score. So it would be z is equal to 63 minus 60 divided by 12 over the square root of 9. Now, when you do that, you're going to get a z-score that's right at 0.75. So you go to your table, you find 0.75, and of course that gives you 0.2734. But remember, that gives you everything from that point down to the other half of the curve. So to get the answer, you basically have to take 50% and subtract that. So basically, you would take 0.50 and you're going to subtract this 0.2734, and that's going to give you about 0.2266 as your answer. So basically, that you do it just like we did in chapter 7, except now we've got this new equation. So now let's do part B. So again, draw my curve again. Again, start by putting the mean in the middle, which is 60. And on this one, it says less than 56. So there's 56. So I draw my line. This time we're going to the left. So let's convert 56 into a z value. So it's going to be 56 minus 60 divided by, again, the sigma was what, 12 over the square root of 9. Now, when we do that, you plug all that into your calculator, you're going to end up getting exactly a -1 z-score. So again, you go to the curve, you find 1. Notice that says 0.3413. It's right there. But remember, that would only give you to the, well, if we were on the other side of the curve, if that was a 1, that's going to basically give you that particular area of the curve. So to get the other apart, we basically need to subtract it from 50. So 50, subtract out the 0.3413, and that would give you 0.1587, and that would be your answer for that particular part of the curve. Now, let's do the last one. Last one says, in part C, we want between 56 and 63. So again, let's draw my curve one more time. Again, put 60 in the middle, between 56 and 63. Draw my lines, and we want that part of the curve. And since we've already actually calculated these z-scores, we know that 63 was 0.75 and that 56 was actually a -1. So at that point, if you basically look under the curve, we want to go from 63 to 60. And if you just look up 0.75 as is, that's going to give you, go down here, 0.75, that's going to give you 0.2734. So that's going to be that part of the curve. And then to get from 0 to -1, that's the same as saying 0 to a +1. Okay, so again, if we just looked up 1, you see that that's 0.3413. So in this case, we're going to add them. So if you add those together, your final answer should be 0.6147. So again, just demonstrating again, it's the same bell-shaped curve, normal curve, except we are, in fact, using the new formula, z is equal to x bar minus mu divided by sigma over the square root of n.